as Martin said at the beginning, we'll talk about digital threads and see how we can include Capella and all your tools of your toolchain to support the synchronized source of truth. So let's go over the introduction, and first we start with the contents. So I will give some, let's say, brief introduction to the need for digital thread, and one of the main causes is to deal with complex systems development. Then we'll see how we can start building our synchronized source of truth, and in which, to what extent it's the foundation for an extended digital thread. And I have a couple of use cases to start with this step. Then we'll see how we can enhance traceability and also make sure we get a model requirement consistency, and how we can link the assets from both these kind of sources across the life cycle. And I have a couple of use cases also to describe that. And finally, how we can unlock interoperability, and in this case, enable model requirement synchronization, also with 2 use cases to illustrate this approach. And finally, we'll have some time for questions and answers and a conclusion. Okay, so let's start with the concept of digital thread. So as I said, we need to deal with the modern system engineering, which is characterized by an increased complexity. So at different levels. First, we have complex systems, and one of the indicators of complex systems is the fact that we're building and putting into service systems of systems, or even family of systems. So which have complexity by the number of requirements, by the interactions, by the independence that each system has. So eventually this increases the need for a digital thread. And because these complex systems also go with complex organizations, so we need to consider different stakeholders, different entities, different projects working together, providers working with manufacturers, and so on. So we need to adapt to the complexity of the systems. And the consequence of these 2 first complexities is that we have complex tool chains. And so that means we need to connect more heterogeneous tools together, make sure that we have a complete understanding of the life cycle and how these tools are connected. And so we can even talk about a step further, which is that we also need to extend this digital thread beyond the physical world, and if including with this concept of digital twin. That's what we're doing. So it's not only maintaining a digital thread of the physical system, but also going beyond that. So that's bringing a lot of consequences for the development of such systems and make sure they're efficient. First, we are multiplicating the heterogeneous tools and the need for them to be interconnected, to establish traceability, to be able to analyze the impact of change, which is more and more prone to happen in such systems because of iterative processes, because of many different stakeholders, different regulations, external factors, not only internal, but external factors that will be influencing the system and bring changes, some expected, but many will be unexpected. And this digital thread is enhancing our knowledge management. It's bringing more information, which will help anticipate potential changes and the related risk, make proactive decisions, and let's say maximize the opportunity risk ratio. So make sure that these changes are creating opportunities and reducing risks for the system, for the organization, or for the users, for example. So the path to reach this extended universal digital thread would be first to decide which tools to use. But in that way, this way, we're talking about a scattered tool chain. So we have a tool-centric approach. So maybe one tool that is covering a broad range of capabilities. We talk about ALM, PLM tools, for example. So they will be covering many different things, but you always have some parts that will be outside this tool. And in that case, you will need to cope with this data and how to connect it to this tool. So eventually, we need to move to stage 2, which is to synchronize all the sources of truth. So one tool that you have to manage many things, but also regulations contained in unstructured documents, modeling tools, simulation tools, etc. The idea is to reach this synchronized source of truth, which is giving us a global configuration management at lifecycle level. Then we build the digital thread by linking these different sources together, using the synchronized source of truth as the core, as the basis. And therefore, we switch from a global configuration management to a global impact analysis. And finally, once we can have these tools connected, we can enable what I talk about, unlock the tool interoperability, which means that we can use the traceability and the impact of changes to generate actions, data migration, merge, synchronization of assets between tools. And so that's the final stage that we want to reach to champion the digital thread. So I have a set of use cases that I will be presenting throughout the webinar to step-by-step show how we can increase the level of this digital thread. So stage 1 is what I consider to be the starting point. So I'm not considering the first approach of choosing the tools you will be working with. So we are assuming that you already have a tool chain, you already have specialized teams working with different tools, and now the question is how we can link these tools together. So one use case will be covering the connection to a Capella model. Then we'll do the same with Polarion and connecting to a Polarion project. And then we'll see how we can trace these two sources together, how we can create traces that will be contained in this synchronized source of truth, and what this brings for the user as a capability. And then we see how we can use model-based requirements engineering and the underlying model requirement consistency to help writers of requirements have a consistent definition based on the modeled structure. Then we'll have a look at the model requirement synchronization. So how we can bring information from requirements tools to models and the contrary, and we'll see the example of the zigzag pattern as one use case here. And finally, if we extend the digital thread beyond the organization, we'll need also to rely on remote connections. So federating not only connections inside an organization. So by connections, I mean retrieving data from different sources, but also outside the organization, connecting to other federated sources of truth, such as this one, to reach another model, another system definition outside the organization. So the first step, the foundation, is this synchronized source of truth. So I'll base most of my use cases on a solution called SES Engineering Studio, which is enabling the notion of interoperability hub, what I call SSoT, synchronized source of truth. So it's not a one-to-one connector. We are connecting all the tools to the same hub, so we're destroying silos. If I'm connecting to one source, then I'm connecting to another source. The objective is to make sure they're consistent. So I don't want to have duplicates. I don't want to have contradictory statements. So the goal is to make sure that I understand globally the project. We're not wiping out the existing sources. So this is a synchronized source of truth. It's not an authoritative source of truth. So it exists only because we have these different tools connected. If we don't have these tools here, this is just a database that contains knowledge to trigger tasks. But the tasks need to be applied on existing sources, your authoritative source of truth. So that's why most of the time in these stages I was mentioning, stage 1 is considered to be like a prerequisite. Like, you know which tools we'll be using, but we need to figure out how to connect them together. So tools that can be from different disciplines, different languages, and so on. So we move from stage 1, which is the scattered SE tool chain. So we have different tools that are found in different stages of the life cycle. And what we want to do is to bring them all together to connect into a same hub to be able to have a global configuration enabled. So to do that, we need one thing, which is a capacity to connect to these sources, which is universal. So that means whatever source we have can be connected through the use of source APIs provided by the editors to convert this data into an internal data model that will be understanding all the different assets in a generic way. So a requirement coming from a Doors project, Siemens Polarion, GoBeamer, and so on. So I'm not going to name them all, but the idea is here. So you want to be able to bring this information into this data model and say, okay, if it's a requirement, the object type is a requirement. I don't want to know if it's coming from this or that tool. I want to consider that as a requirement. And so that's opening the possibility to have a digital thread between different tools and federate this data. So the same happens with models and the modeling languages. So we can also convert models from one language to another. And for the example of Capella, that would be convenient. If you want to migrate models from one tool to Capella, that you could also do that. And so this synchronized source of truth is made of two main parts. One is the assets repository, so all the connections that are brought through these APIs and the connectors, and the knowledge base, which is in that case of the connections, can help, for example, parse. Let's say one example would be to parse a Word document and find the statements that have a shell structure, like a subject, a valid subject, and a shell. So we can tell the tool, okay, bring only to the database, to the repository, the requirements that have a shell word. We can do the same with Capella. We can do the same with any of the tool here. The idea is to have this universal connector. And so for in the case of Capella, and here I'm using version 7, which I recently downloaded from the website. Here, this is how we can have this universal connector featured. So we connect to the model. We have a project view. So this looks familiar for the Capella user. It's the project explorer. We can see the different icons. So the icon is part of the information that comes from the source. So that's why we use it, because it's helping the user to identify the object. If I remove the icons, then maybe that's not that clear. So what kind of relationship is that? What kind of feature is that? So the icon is also part of the information the connector is bringing. And together with that, we can also bring the snapshot of the model. So we're not replacing Capella. So we're not converting the tool into a modeling tool, but we give the ability of the tool to read models and synchronize them with other sources or trace them to other sources. So that's what we do here, and we'll see different examples in the next use cases. So the universal connector is checking if there's a change. So remember that I said the importance of change and how to track changes across the life cycle. So by doing this synchronized source of truth, what we do is any change that comes from any of the sources connected to this hub will be detected. So if the source is saved, so it's in loaded permanent state, this repository status is updated. So that means something was changed from the source and has generated another version that is about to be saved in the tool. So you'll see in the examples that's pretty easy to understand. So that means in that case, what I'm expecting from the tool is to save this change coming from the source to the repository of the tool, the synchronized source of truth. So that's the use case of the source provoking the change and synchronizing this change into the database. But we could have the opposite way. We have a bidirectional here behavior. So you will see that also in the different clips that I have. So in that case, if I update the synchronized source of truth, I'm getting an update status notified, and the source is about to be updated as well. And so when I save this here, it will be saved both in the repository and the source. Source, by source, I mean any of the connectors that are available in the tool. We have about 50 connectors that work that way. So what we want to achieve here is to have this state here. That means we need to have the two sides synchronized. So if one change comes from one side, I need the other side to be on the same page and the opposite way. That's a prerequisite to do traceability, for example. I cannot trace objects within this tool if I don't have a synchronization done before. So you see, just by saying that this opens the ability to detect suspect changes, for example. So together with that, we can do universal connectors mean universal configuration management. So we have objects represented, as you saw in the previous picture. So these all are objects, and these objects can be versioned, and the whole model can be baseline. So we can baseline the Capella model in this tool, and by referring to the previous slide, that means we can revert a model to the previous version using also this capability. So we can compare these different baselines, see what happened here. For example, I have, that's the example I will be showing in a few minutes. So we changed the name of the function. So we see that it's display temperature here and display ambient temperature on that side with the updated state. And what we will see in the comparison is that, okay, we changed the name of the function, and we have a summary added as well in this object. So let's look at the first example. So we have here an example of a project that already has some connections. We're going to create a connection to a Capella model. So in this version, we have two ways to connect to a Capella model. One is to connect to the project, so the workspace. So we're interacting with the model. In that case, we're enabling a bi-directional synchronization and behavior. If you connect to the file, it's just a one-sided connection and a read-only connector. It's just to read the functions, to trace them. So you could use the function, the files, or you can use the project, the workspace. So here I'm connecting to the workspace. So you select the workspace in your directory, and then by connecting to the workspace, you see the projects that are available. So here I have just two projects in this workspace. We can enable the snapshots to be loaded in the connection. So that's the behavior we saw before. And then if we, for the basic setting, we can just go to the information tab, name the connection, and also there's an ability to share the connection. So if another user connecting from another computer want to have the same setting, so we can make these settings available. Otherwise, it's not saved in the database. It's saved in the local repository, in a local folder, and only the user that created the connection would see this new connection that we will see on the screen here. So the Capella connection is created. So then we can open this connection and see how this is going to be featuring the different elements of the model. So we're replicating the Project Explorer, and then based on that, you can navigate through the model. You can start tracing. So we'll see the traceability aspect after, but the idea is just to understand how we can synchronize data from external Capella models. So you get this here. This is loaded because that means I already loaded this before and already saved this to the repository. The first time you connect, you get a green background with the new state. That means it's new to the database and it's waiting to be synchronized with the database. So you will see that in some examples as well. So we can see some information that is gathered by the connector, the summary, the type, and more. And you can see the diagrams that are replicated. So from the Capella model. So that is increasing the understanding from the model for someone willing not to be an expert or to edit the model, but to connect this model to other sources. And so then once we do that, we can check an example of modifying a function. So that's the example that was displayed in the previous slides. So I'm going to the logical functions and getting, for example, this display data and display temperature example. And so this example here is, okay, changing the display temperature to display ambient temperature, adding a summary. So that's what we did in the example. So we saw the result. And now we see how we can get to this result. So exactly by doing that, so you're working in Capella, you save your model, and then all of this happens at the same time. So you can refresh the model. If you're not connected, then you connect the next time and you will get exactly the same result. But since this is done in a one-shot sequence, then the connection is still open while the model is being modified. So that's why in that case we would hit the refresh button. But disconnecting and connecting after the model is modified would be the same behavior, which is to get this updated behavior here for the objects that are concerned. So the folder is modified because the logical architecture layer is modified, because the logical function is modified, and so on. So you navigate through the levels until you get to this corresponding object, which you can check what it changed. So we changed the name and we added a summary. So, and you see there's a revert button on the top. So that means if we want to revert to the previous version, then we would click on revert. That would keep the version 1 of the object before the change. And if we hit save, then we would push this reverted version to Capella. So that would be the back the reverse direction. And we'll do a bidirectional synchronization here. So while this is being updated, we are updating something within this tool here, and changing, for example, the name of one function, so the one just above, and display time is becoming display battle time. So we can save this here, and this is going to be saved, and you see that the message is saying that we save both in the source and in the database. So that means we're synchronizing. So the database, of course, is keeping this information, and the model is instantly saved. So the model is opened in the background. And so now we can check the other connection that we will need to perform the traceability, which is the connection to a Polarion project. So connections are available for the users. Of course, you need credentials of the source tool to connect. So if you're not allowed to connect to the project from the source tool, you won't be allowed to connect to the project from the tool. So even though we're creating a synchronized source of truth, there's no magic here. The authentication is still there to make sure that the right user accesses the right information. So of course you're going to be asked for that. So same way we connect to Polarion. So users familiar with Polarion probably are recognizing some of the icons representing the work items here. So same thing as with Capella, we reproduce the icons to make sure that we increase the understanding of this view for someone already familiar with the tool. And the columns here that we see that are displayed are the corresponding to the generic view. So these columns can be all these views can also be customized. You can add your own attributes, whether attributes that are created in this synchronized source of truth or attributes coming from the source. So we'll do something quite similar here, which is first provoke a change here. This way we're using this editing window. So those who are familiar with the RAT plugin for Capella, so that's the RAT embedded inside this solution. So we still have the RAT for Capella for the people writing requirements in Capella, but here that's the same approach. We edit the object, we see the quality moving in real time, and we can save an updated version. So this is about to be updated. This time we have the two colors, one for the first column for the source and one for the repository. So which will be consisting in synchronizing the information. So the message again will be both saving in source and in the database. And so that means we can go back to Polarion and see what happens. So I'm getting back after a short while, so I'm going to be requested to log in again. So, and then I'm getting the description updated. So the description has updated. I could have updated also the title, but since we're talking about the same thing, then I'm not changing the title. So here we can do the opposite way to test the bidirectional behavior. So we started the opposite way in this one. We first did the change inside, and then we do the change in Polarion. So here we're creating a change with the title and description, and we'll see what happens on the opposite side. So if you're wondering what this icon you see here means, you'll see that in a few minutes as well. So I'm not going to spoil about this. It's going to be explained in a few minutes. So we do this change here. We refresh again to see what happens from the synchronized source of truth perspective. And so we reload all the objects that were selected in the connection configuration, and we'll get an updated state for the work items and objects that are considered here. If we do the view changes with the source this time, we see that both the description and the header change. So the name header here, maybe it's not exactly how it is called in the source tool. So the name that is used here is already the generic name. So the header can be called object short text in Doors, can be called title in other tools. But for all these tools, it will be called header. So see, if you anticipate a little bit, you will understand how we can enable data migration just by saying, pick the header from this tool and copy it into the header from the other tool. And the tool will understand that in one tool it's called the title, and the other tool is called the summary, for example. So that's also one way to understand a little bit more how we can synchronize data between the tools. So that's it for the first layer, which is to set the foundations for the digital thread. So now we will see how we can extend the traceability throughout the lifecycle by building on top of this synchronized source of truth. So we're moving from stage 2, which is a universal connector approach that's bringing all the sources together inside one repository and creating a backup copy at the same time, because you are able to revert versions and so on. So from this model to a digital thread model, creating links between the different sources. So end-to-end traceability and global impact analysis are enabled together with the suspect links detection. So we'll see some examples. So here, what we want to reach as a result is something like this, a traceability map that includes different tools, not only one single tool that is creating all the traces. So maybe you can ask yourself, and what if I have traces within the same tool? So we're able to bring these traces also inside the synchronized source of truth to increase the traceability map. So of course, there's no better tool than the tool itself to do a trace that is internal. But if you have some traces that are external to the tools, some others that are internal, then why not bringing them all together in the same repository to make sure that we all have a broader understanding of the traceability map. So some indicators can be shown here, the percentage of elements that have been traced, the number of traces in total, and so on. And then you can access detailed information for each pair of connections. So the idea also through this layer is to increase the understanding of the tool to, for example, provide with guidance to write a requirement that is going to be consistent with the model. So to do that, we power the ontology, which is let's say the main part of the knowledge base, which also is comprised of the data dictionary and a model that features diagrams, relationships in general, that will be providing better consistency. So we'll see an example how this can be helping writers of requirements on the fly. So let's see two examples here. The first one is the traceability. So we're starting from where we were talking in the previous slide. So with this traceability map, and so we're going to create a traceability here module. So we name this here with a certain name, and we add let's say a link name. So the links can be added in the tool to create these traces. And so then we have the ability to select some algorithms to detect suspect traces. So we want to check the description has changed. If only the modification date changes, but not the description name, then, or name of the model element, then that's not enough. Then we add this to the traceability map, and we can start tracing. We can do manual tracing. We can do suggested traces based on algorithms. This one is going to find the pairs that feature the name of the model in the requirements. So in that case, we would see that, for example, this one would be discarded because shortage, it's finding it, but we don't want to keep it. But the rest here, every example here of requirement is featuring the corresponding name of the model. So we can show the impact analysis here to see the elements that are traced together. So one requirement in Polarion is traced to two different model elements, requirements or risks in that case. So any work product that is connected. And we can see that here we can see the traceability details. We can accept a trace here because it's suggested, so we need it to be consistent, which is the state of an accepted trace. And so then we can check the impact analysis. This time the arrows are not dashed, they're continuous, meaning that it's in a different state. We can also see the traceability matrix if we want, and also select different traces and accept them at the same time. So I'm going to speed up a little bit because I see that we're also we have a time constraint, so I don't want to spend too much time on that part. So now we change the element of Capella here, an actor in this diagram, and we'll check what happens if we do that. So first, we'll do exactly what we did in the first place, in the first set of clips. So that's why we're building on top of these foundations. We're getting we're going to get, so I'm going to speed up this loading here. So we saw how in real speed how much time it takes, but here we see it's updating the model. We have a new name for the opponent. We can save this new version, synchronize it to the repository. Only database is being saved this time because the model is already saved. And once we do that, we can hide the model here. Then it can be reopened again. And then once we go to traceability, we can see again the map. We can look at the traces, both by using the right click or left click based on what you want. And we can evaluate the suspects in these traces. And so the tool is going to tell, okay, this is my suspected trace. And then we can see why. So this is a suspect trace. It's detecting that this one is suspect. When we double click on it, then I'm going to zoom in a little bit here. So it's saying that the target is a suspect trace. The opponent is what changed here, the name, and the updated summary. I added the word rival to refer to the previous name of the object. Okay, so then we can accept or delete the trace based on what we want to do with this suspect here, or we can use the right-click options to accept this trace here. Okay, so that's one approach to extend the links between the different connections. Another example. So I told you before that I would explain what this icon means. So it's an embedded RAT again, RAT this time not in Capella, as you already know it. We have other webinars that present in detail the RAT for Capella. So this one is the embedded web extension that will help us write a requirement with the help of the Capella model. And we'll see why I'm saying that, because this is apparently not related, but I can select a pattern that features elements that come from the model. And so the pattern is going to suggest terminology that will help me structure the sentence. So I'm following a pattern. I'm getting some suggestions. So temperature drop, then I have an operator, I have a value, then I will have measurement units. I still need a model verb, so that's why on the left side it's telling me that I need a model verb. It's also telling about the tolerance value. So this is something that can be skipped if we want to disable this metric. And I keep writing. So I can fail while following this. Here I'm using an example that allows many different model verbs. This one is not allowed, so I can find it and mark it. And if I go back to the right model verb, then I can follow. It's a state transition, so it's transit. In that step, it's the initial state. I could have any of the initial states available. But let's see what happens when I select here combat mode 2. And that's the only option that is leaving, the model is leaving to me. So based on the initial state I'm selecting, I'm only getting this final state suggested. So you could do the same with other modes. Would be the exact same behavior. And finally, when you finish with that, you can save here. The save is not actually saving in Polarion, so it's a front end window that is a pop-up window that is editing the text. So once the text is edited, then you can save in here. And so this would work in any of the extensions. So if you have web-based deployments, that would be also helpful. So after we do that, after we link the elements together, we have to move to the final stage, which is to enable information exchange between the tools. So sometimes we'll see some examples. We need to have the information that is managed, traced between the tools. Also, we'll need this information to flow between the tools. So that's what we call the interoperability, which can have different applications. So the interoperability, like the rest, is built on top of the foundations. So the connectivity, the traceability. And so the first type of interoperability is the ability to transfer work products. So what I mean by transfer here is there is no change of meta model between source and target. We're just moving the different tools. This here is going to map descriptions with descriptions, attributes that could be textual, but still with the same approach. So an author is an author, a stakeholder is a stakeholder, and so on. They can be named differently, but it's not changing the data model. So I have a number of attributes on the left. I'm not going to convert these attributes into something else. So the text is going to be text on the other tool. So we're going through these transformation rules, which are let's say the connectors, and we end up with text here. Transformation is a little bit more tricky because we need to change the data model between the different tools. So a textual tool source, like a list of requirements coming from any tool, even an Excel sheet, could be converted into a set of textual requirements within Capella. And also it will be converted into the data model of Capella, because you need these requirements will be converted into objects of the model. Concretely here, we could create, for example, requirement objects using the requirement viewpoint of Capella, and that would be one transformation. So this would be used, for example, in the Zig-zag model. So I'll include a link. I'm including a link after about this if you're interested in this approach. So the Zig-zag model or Zig-zag pattern is representing how we flow requirements to the models to trace the information to the modeling elements, and then flow them back to requirements management tool to build the lower level elements and so on. So this is presented in a webinar that I'm including the link for here in this slide. So another case of transformation is the conversion of models. So SysML could be converted into ARCADIA Capella, considering the example of migrating data from one modeling tool to another. We can generate requirements from models. In that case, we have model elements, logical architectures, functional breakdowns, actor diagrams, etc., that will be converted into text. So you can use the actor diagram to say one textual sentence. The opposite way could work as well. We can use text and the way the text is structured to convert the text into models. So we have different options. And so the final step of interoperability is, what if I have to go beyond organizations and how to exchange information between organizations? So my organization has different departments working together. So they could be working in parallel and exchanging information that way. One department could be also involving external organizations, and they could also be exchanging information together. But eventually, we need to enable what we call a remote access. So in that case, we would create a gateway for external clients to access tools and connections that are not available on client side, tools that might be available on client side, which means I could run the connection using the gateway and run a Capella model that would be run on server side. So that means, concretely speaking, that this client application could run a Capella model and see the structure of the Capella model without having Capella installed on its machine, nor having the workspace in here. So in particular cases in which you want to collaborate between organizations or between teams that are not having the same setup, then that would be interesting to have as well. Another option is to enable collaborative work. In that case, we have two repositories that are linked to the corresponding organizations. And by enabling this collaborative work, changes brought to one connection and synchronized to this repository could be also synchronized to the other one. So that's creating a federation of repositories. So it's creating another level of federation beyond the projects. So I'm having some examples of this here. I'll go first with the example of requirements transfer between two tools. I'm using the same pair of tools here, so to use the same thread since the beginning. So in that case, same thing, I will be opening one object. So first, one project. First time I open it, it's in a new state, waiting to be synchronized. And then, so I'm going to speed up this one, so because you already saw this part of saving and synchronizing. Then in Capella, I can have attributes created. So author, priority, and so on. And then I can open the connection here in the tool, and I'm going to get the information that this has been updated. So I can configure here the module to load attributes from the source. So I'm getting these new attributes loaded. So I'm adding more information to be synchronized with the source of truth, the synchronized source of truth. And by opening this model, I'm getting the same here, a new state until it's synchronized. And for the corresponding requirements, I can add an attribute to the view to be able to see this new information. So that's what is done just after here. But before that, we can execute a task of interoperability to bring this new set of requirements to the other side, to the to Capella. So I'm bringing new requirements to the model. So here on the background, we have the temperature warrior system requirements, which is the name of the system of interest I'm using throughout these different clips. And the control system is one of the subsystems here. So I have default attributes displayed in this view, and I can go beyond that. So these new attributes, these new requirements are loaded here. We can add information here, change the values. We can also change the format. We underline and in here we can add long information to the long name. So many changes here that I will be brought. So several changes at least, and then we can do the same with the attributes and so on. So just going to skip this part here. Also, attributes are going to be assigned. And so what I want to show here is that I'm bringing these attributes here by refreshing. I'm bringing these attributes to the view here. So I'm getting this information synchronized with the synchronized source of truth. I can add attributes to the view. So I'm just going to add this here. See, the priority is added on the right. So here we see the attributes are added, and then we can change these attributes here. I'm adding just all of them just to check, just as an example, that they will be written back to back to the source. And so if by saving that, this is going to be saved. And you see that here we have all the attributes values here. So it's not only changing the description of a model element, it's also going beyond that, changing attributes and so on. So here we're changing values, we're changing formats here, and we're going to do the other synchronization here, which is going to bring this back to Polarion. So here in this view, we're updating the Polarion elements by merging all this information together, and that's going to be synchronized back to the source tool. These requirements have the new value 5. We have the underlined term here, and we have this bold and underlined as well here. So basically that we can flow through from the model to the requirements tool back and forth. And so finally, the other example that I was showing with the extended connectivity through remote connectors is by enabling a server to be turned on by one side and the client to connect to this server. So I'm going to show here one connector. So it's not a connector to a tool; it's a connector to another repository. And so this repository includes different connections. So we are aware at that moment that someone is connecting, and we're getting the information from the different sources that are available and put available by this server to be connected remotely. And so in that case, we name the connection, and it's created as a connection like any other. The only thing is that I'm not connecting to a tool that is in my environment. I'm connecting to a remote server that is going to itself show the connection. So this is accessed remotely. The same document is accessed remotely, but since it's accessed remotely, the other database that has information here is considering this new, because that's the first time we're using it here. So once it's synchronized, it's getting also loaded on the other side, and we can create traceability between the different tools here. So I'm going to skip this because that's what we saw in the previous slides. This is creating a traceability between the different elements manually in that case. And then when we execute a change here, we change the ready state here to ready mode, or prepared state in that case. We change the name basically of the state. And this on server side is going to be offered by the server to the client. So I'm getting a connection updated again. And I'm going to see the change here for the client. So that means all the behavior that was shown before, suspect links detection and so on, but extended beyond one environment. So that's, let's say, basically a summary of what we saw before, but beyond one single environment. Okay, so now I'll leave some time for questions and answers. So Please let me know if you have any questions now.
Perfect. Thank you very much, Ilyes. Is SSoT a commercial tool?
Okay, so the name of the tool is not SSoT per se, it's SES Engineering Studio, which is implementing this concept of SSoT, and yes, it's a commercial tool.
Next question. How does this work with respect to data security models, whereby some information may or may not be available to some people throughout the life cycle?
Okay, that's a very good question. Here, I didn't address this part of restricting the access to some connections. So you can, so in all the clips you saw, you could click on any connection because I'm just a single user doing some work. But if you're working in a shared environment, then you can also define permissions to either access or not the connections. Even before the connection, access the project because the connections are included in this SSoT. So we can restrict the access to the SSoT as well. And if you want to do it from the source tool, if you have the ability to do it from the source tool to restrict the access to the content, you can also do it as well. So it's configurable. It's not something that is like open to everybody. So, and it includes also in the internal task of the tool to modify or not, or trace or not the elements to another connection. So hope that answers the question.
How do we integrate with existing enterprise workflows, for example, CRM, ERP, or other SaaS tools?
Okay, that's a good question as well. In that case, so I mentioned a number of connectors. So basically, the workflow would be the following: if you don't have the connector today from this tool to your CRM or ERP, then that means you would we could investigate if you can create this connector. And one other option that is also going to be considered in the next version is the ability to provide an API so that people can grab information from this SSoT and use it for indicators. So I know people that requested to have a Power BI, for example, grab these data and create indicators. So that would be an example of how we could provide an API to support your existing workflow. So most of the things I showed were from the SSoT point of view, connecting to the external sources, but we want to do the opposite way as well, so that all the tools that have this ability to synchronize data, that they can grab the information from the tool as well.
Have you defined a method or best practices for selecting the right source for the right concept? And how do you deal with the situation where several sources contradict each other?
Okay, so two questions in one. Go one by one. So method or best practice for selecting the right source for the right concept. So by right source, you mean the right tool, I guess, or maybe I'm not understanding it the right way. So best practices. Most of the time, what we try to do is we try to stick to what is currently implemented. So, of course, we can recommend to shift a little bit the way things are done today in an organization. But if we talk about the tools, production tools to manage requirements, to manage test cases, to manage simulation, so we cannot say, okay, select this tool or select that tool. So we try to be neutral, and what we want to do is help you with this synchronization. And of course, if there are things that can be improved, then we can give guidance. But we're not like picking sides in terms of sources. So that would be my answer for this one. And the second one, so the situation where sources contradict each other. So in that case, if the contradiction can be checked by the tool, it could be through this suspect links that I was mentioning is one way to detect that something is in contradiction. So we saw an example. The entity is called rival system. on both sides, then one side decides to change the name to opponent, then we can detect that the other side is has a suspect link to that one because it's not having the corresponding names. Or if it's within the same document or the same source in general, if you have conflicting statements or similar statements that may be found, then we can also help with that as well. So there's an LLP engine that also works to find duplicates. That's a good question as well, relating a little bit to all we saw. So good question to, let's say, to close here for a conclusion. So it links pre-established elements, of course, because we synchronize these elements to the synchronized source of truth. But the last step that was presented in this webinar, which is the interoperability, is in fact the ability to migrate data from one tool to another. So say here, I used Polarion in these examples. You could think of any tool that can be connected through SES. We can take this information and create the new elements in the other tool. So we can bring new elements, requirements, risks, test cases, issues, so you name them, from one tool to another. So that's part of the capabilities that the interoperability is providing. And so creating with or without transformation of attributes, of models, that's up to your configuration. So the first one without transformation would be easier to do, because we don't have to configure a lot of mappings.
Thank you very much, Ilyes.